All right, so in this video, we're going to look at the sigma summation notation. So this symbol here is the Greek letter sigma. Okay, this is the Greek letter sigma. This one in particular is the uppercase Greek letter sigma, uppercase. So it's a capital letter. The lowercase is this one here. So this one is the Greek letter sigma, but this is lowercase. Now, in mathematics, the Greek letter sigma, the uppercase, is used to denote summation. Okay, so it's used as a shorthand for summation. So the expression so if we write this expression here, f of n, suppose we write here n equals 1 to n equals to 3. Okay, what this expression is saying is add up all values of f for n running from 1 to 3 inclusively, taking all integer values in between, so going from n equal to 1 to n equal to 3. Maybe let me just change this to n equals to 4. The n equals 1 is called the lower summation limit, or just the lower limit. So this is the lower summation limit, and then the n equals to 4 here is called the upper limit, or the upper summation limit. Okay, so what we're saying is this thing says add up all values of f for n going from 1 to 4, running between 1 and 4 inclusively, taking all values, integer values in between. So the first one would be obtained by plugging in n equals to 1 here. Then the next one, the next integer after 1 is 2. Then after 2 we have got 3. And then the upper limit is going to provide us with the last value of this summation. So that's basically how that works. Now, notice that this is going to be convenient, especially for large sums. You can imagine if the upper limit was 40, then that means we're going to have 40 of these, but we can still write it in this short form here. So like I said, so that sigma notation is a shorthand for summation. Okay, now so let's look at some examples. Okay, so in this first example here in number 1, we are expanding. So it says expand each of the following summations. We're going to do A, we're going to do B, and we're going to do C. Then we are going to go to number 2. And number 2, it says evaluate, expand and evaluate. Evaluate means find the value of. So in number 1, we're just going to expand. We're not going to find the value of the summation. But in number 2, we're going to find the value of the summation. In number 2, we're going to do A, we're going to do B, and we are going to do D, enter E. Then we'll give you some for practice. All right, so let's start with number 1A. Okay. So examples here. Number 1A is a summation of n squared plus 1 from n equals to -1 to n equals to 2. Okay. The first value of this is going to be obtained by substituting n is -1 here. So we're going to have -1 squared plus 1. Then the next integer after -1 is 0. So we're going to substitute 0. So 0 squared plus 1. And the next integer is 1. So 1 squared plus 1. And the last one, which is the upper limit, will be 2 squared plus 1. Okay. Question hasn't said evaluate. We're just going to simplify this. So this first one is going to be 1 plus 1, and the next one is going to be 1, and the third one is going to be 2 again, and the last one is going to be 5. All right, and then in part B we have got the summation of -a to the power m. M is starting from -2 to 2. So for the first value, we substitute m is -2. Then plus for the second value, the next integer is -1. Then the next integer is 0. After that, 1. And then the last one is going to be -a squared. Now, from properties of integer, negative power means reciprocation. So -a to the power -2 is 1 over -a squared. Similarly, this is 1 over -a. -a to the power 0 is 1. -a to the power 1 is -a. Then -a squared is a squared. So then finally there's going to be 1 over a squared minus 1 over a plus 1. This is going to be minus a plus a squared. So that's going to be the value, the expanded version of that summation. In part C, we have got the summation of we've got the summation of 5i minus 4. I is running from 3 to 6. So for the first one, we're going to have 5 times 3 minus 4. And then for the next one, the next integer is 4. 5 times 4 minus 4. Then 5 times 5 minus 4. And the last one is going to be 5 times 6 minus 4. So that one's going to be 15 minus 4, which is 11. Then after that, it's 20 minus 4, which is 16. 25 minus 4 is 21. And this one is going to be 26. All right. So that's that in number 1. We're going to come back to number 1 a bit later. Right now, let's go to number 2. So in number 2, the instruction is expand and evaluate. So here, The advice is to work out the first three terms. Okay, so work out the first three terms plus the last term. This is going to enable us to determine whether the summation at hand is a GP or an AP, as you will be aware in this topic we're doing APs and GPs, so the summations involved will involve one or the other. So here we are summing from n equals 5 to n equals 200. So as you can see, there's going to be lots of terms involved there. So we're just going to do the first three and then the last one. So the first one is going to be 7 times 5 minus 3. Second one is going to be 7 times 6 minus 3. The third one is going to be 7 times 7 minus 3. And then these dots mean there are lots of terms in between. The last one is going to be 7 times 200 minus 3. Okay, then we have got to evaluate each of these. Okay, so the first one, 7 times 5 is 35 minus 3. It's going to give us 32. 7 times 6 is 42 minus 3 is going to give us 39. And then 7 times 7 is 49 minus 3 is going to give us 46. And then the last term is going to be 7 times 200, which is 1400. If you take away 3, it's going to give us 1397. So that's going to be the last term. Now if we check the differences here, the difference 39 minus 32 is 7, 46 minus 39 is 7. So the differences are the same here. So that tells us that this is an AP. So this is an arithmetic sum. So we are going to still remember the formulas for arithmetic sums. So in this case, we can see that T1 is going to be 32 and Tn is 1397. D is 7. The question is, how many terms do we have? And that one, usually we can work out from these limits here. So the number of terms is always going to be the upper limit minus the lower limit plus 1. So n is always the upper limit. Let me just denote it UL. N is always the upper limit minus the lower limit plus 1. So in this case, it's going to be 195 plus 1. It's going to be 196. So remember, our formula is n over 2 T1 plus Tn. So for this one, it's going to be 196 over 2. 32 plus 1, 397. Then if we punch this in the calculator, it's going to give us 140,042. All right, so that's the first one. Go to the next one. All right, so we go to the next example, which is B. So B is the summation of 10 minus 4n, and n is running from minus 10 to 90. So summation of 10 minus 4n, n is going from minus 10 to 90. So again, we're going to do the first three terms. So 10 minus 4 times minus 10 plus 10 minus 4 times next integer is minus 9. Then 10 minus 4 times negative 8. And then the last term is going to be 10 minus 4 times 90. Okay, then we evaluate these. Okay, 10 minus 4 times negative 10 is going to be 40. This becomes plus 40 plus 10, so that's going to be 50. This one is going to be 4 times 9 is 36 plus 10, so that's going to be 46. Next one, 4 times 8 is 32 plus 10, so that's going to give us 42. And then the last term is going to be negative 350. It's 10 minus 4 times 9. And then using the formula we just talked about here, the number of terms in this one going to be 90 minus negative 10 plus 1. It's going to be 101. First term is 50. The last term is 350. And so if we punch this in the calculator, it's going to give us negative 15,150. So that is B. Going to skip C, and we're going to go to D. So in D we have the summation of 25 times 1.03 to the power n. N is going from 0 to 100. All right, so first term is going to be 25 times 1.03 to the power 0. Then 25 times 1.03 to the power 1. Then 25 times 1.03 to the power 2. The last term is going to be 25 times 1.03 to the power 100. Yeah, for these ones where n is a power, typically we just need to simplify the first one. So 1.03 to the power 0 is 1, so the first term is just going to be 25 here. And then the others, we can leave them exactly as they are. So 25 1.03 squared here, and then 25 1.03 to the power 100. Now these ones, this one is not going to be an AP. Let's see. Yeah, this we didn't talk about it being an AP, but if you work out the differences here, you're going to see that 50 and 46, the difference is negative 4. 46 and 42, negative 4. So these ones, yeah, maybe just for purposes of instructional purposes, let's just do the first three. Yeah, so, and then we're going to show you that they actually don't give us an AP. So let's do so 25 times 1.03 is 25.75. And then 25 times 1.03 squared is 26.525, and then this goes on. So if we try to do the differences here, so for this one it's going to be 0.75, and then for the next one it's going to be this one minus 25.75, and you can see that that's going to be 0.7725. These two are not equal, so that means it cannot be an AP. So then the next thing we do is we try to divide them. If we try to divide them, so if we do this one minus this one, so it's going to be 25.75 divided by 25, and we get 1.03. Then if we divide this one by this one, so it's 25.5225 divided by 25.75. Sorry, it's actually 26. Yeah, just one moment. It's actually 26. So this one is terribly wrong. So let's just do that one again. It won't change anything. 26.5225 minus 25.75. Oh yeah, it's correct. It's correct actually. It's correct. Okay, so now let's do the quotient. So 26.5225 divided by 25.75, and it's also 1.3. So you can see that the quotient for both of them is the same, and it's actually this number here. So that's telling us that this thing is an AGP with the ratio is 1.03, which is that number there, which keeps occurring. So we've got a GP. The next thing is how many terms we have, but for a GP we do have a formula that does not require the number of terms. If we know T1 and we know Tn and we know the ratio, this is T1, this is Tn, we have got the ratio here, then we can find the value of this summation using the formula T1 minus R into Tn divided by 1 minus R. So T1 is 25, R is 1.03, Tn is 25 times 1.03 to the power 100. Okay, then this is divided by 1 minus 1.03. Of course, if we factor out 25, then you can see that this is going to be 1 minus 1.03 to the power 101. Okay, divided by 1 minus 1.03. And then if we punch this in the calculator, it's going to give us 15,662.66. Some of you may be thinking how does that work? So let's see how this works out. So it's going to be 25 times, then open brackets, 1 minus 1.03 raised to the power 101, then divided by open brackets 1 minus 1.03 equal, and there you have your 15,662.66. We are typically rounding off to decimal places. We do that right at the end to obtain maximum accuracy. Okay, so now we're going to go to example number E. Example number E, we've got the summation of 45 times 7 over 9 to the power k, for k going from 0 to infinity. So this is an infinite sum. The only time we have come across an infinite sum is when we were dealing with infinite geometric progression. So as soon as there is an infinite sum, that must give you a hint that it must be an infinite geometric sequence. All right, so the first term is going to be 45 times 7 over 9 to the power 0, followed by 45 7 over 9 to the power 1, 45 7 over 9 to the power 2. This time we've got an infinite number of terms, so we cannot go to the last term. We cannot get to that term, so we just write the first 3 terms. So the first one is just going to be 45, because 7 over 9 to the power 0 is 1. And then again here, 49 times 7 over 9, then 7 over 9 squared here. Now this again is going to be a geometric sequence, because you can see that if you divide this by this, you are going to end up with 7 over 9. If you divide this by the second term, you're going to end up with 7 over 9. So this is going to be a GP with ratio 7 over 9. 7 over 9 is in the interval, is between -1 and 1. So this fits well into the infinite geometric sum. So we said this is our formula. T1 is 45 minus 7 over 9. So this is going to give us 45 times 9 over 7, which works out to, sorry, this is over 2. So this is going to give us 202.5. All right, so that is that one there. So just one moment. So that was E. I think that's the last one we're doing. So at this point, we're going to give you a chance to have a go at some of the exercises in number 1 and some of the exercises in number 2. So you will preferably want to pause the video and then have a go at those ones. Then when you press play again, then you can compare. So if you want to have a go at D, E, and H in number 1, then in number 2, if you'd like to have a go at F, G, and H. Okay, so just press pause and then have a go at those ones. All right, we're now going to scroll down to our worked out answers. we strongly advise that at this point you have tried the exercises ticked in blue. That way you're going to gain the most from these videos. All right, so I'm gonna scroll down to number 1D. So number 1D, we are summing from -3 to 0. Our function is 2k squared minus 7. So if we plug in -3 here, then plus we might plug in -2, then we plug in -1, then the upper limit is 0. We plug in 0, so these add up, work out to 11 plus 1 minus 5 minus 7. For E, the function is 7 minus 3n. We are summing up from -2 to 1. So when n is -2, this is going to be the expression. And for n is -1, n is 0, and the last one when n is 1. These work out to 13 plus 10 plus 7 and plus 4. This time the expression is a to the power 3 minus k, b to the power k. K is running from 0 to 3. So if you plug in k is 0, that's the term. K is 1, k is 2, k is 3. Then we simplify the powers, and these are the terms. You can see that these look like a bit like the binomial expansion terms, where in all the terms the powers add up to 3. Okay, then in number 2, expanding and evaluating. For f, we're starting from 1 to infinity, so it's an infinite sum. It must be geometric. But the thing you want to be careful of here, this one starts from 1, not from 0. Okay, so we do the first 3 terms. We work out the first one, works out to 15. These ones, we can leave them exactly as they are. And so r here is going to be -3 on 4. So since it's an infinite sum, we're going to use the formula T1 over 1 minus r. It's going to give us that situation there. Then this is going to work out to 8.57, correct, to 2 decimal places. In G, the function is 70 minus 9j. J is running between -20 and 600. So your first 3 terms are 250, 241, 232. If you work out the differences here, they're the same. So this one is an AP. And so we plug into the formula. It gives us -1,577,340. And the last one, which is H, again, so this one is a finite number of terms. If n is a power, then chances are you have got a geometric sequence. So this is geometric. Those are the first 3 terms. That's the last term. And we're going to have 51 terms. But of course, you can use the formula that does not require the number of terms. This is going to work out to 35,032,061.61. All right, thanks for watching. Please subscribe to get notified whenever we post some of our future videos. If you find these, well, hopefully you find them useful. Thank you very much. Bye.